Formulae of the chapter Circular Motion. We have to discuss different formulae in connection with the chapter Circular Motion. Number one formula is Centripetal Force. Number one topic is Centripetal Force. In the diagram, we have considered a horizontal circular orbit. This is a body of mass m which will be revolving in this circular orbit. This is a body at the point A, and this body has mass m. O is the center of the circular orbit and r is the radius of the circular orbit. This body revolves in this circular orbit and it has a tangential velocity v along the tangent AT. V is the tangential velocity of the body, and the body will be moving along the curved path AB in anti-clockwise direction in the horizontal circular orbit, provided an external force Fc, means centripetal force Fc, acts radially inwards. Fc is the centripetal force which is acted on the body externally radially inwards, so that the body will be moving in this circular orbit along AB instead of along the tangent AT. The formula of this centripetal force is Fc equal mv square by r. Fc equal mv square by r. So this is the mathematical expression of centripetal force. Mathematical expression of centripetal force. Fc equal mv square by r. Centripetal force acted on a body revolving in a circular orbit, acted on a body of mass m. This centripetal force Fc is acted radially inwards, and the linear motion along the tangent AT with the tangential velocity v, the linear motion of the body along the tangent AT along the tangent AT is converted into circular motion along the curved path AB, under the action of centripetal force Fc along AO. Also, Fc has another expression which is given by Fc equal m omega square r, where omega is the angular velocity of the body. Omega is the ratio of v and r, v by r, which is the angular velocity of revolution of the body, angular velocity of the revolution of the body. And also vector v equal vector omega cross vector r. Fc equal mv omega. So this is the third expression of centripetal force. Fc equal mv omega, product of mass, tangential velocity and angular velocity. Now, a body of mass m at the point A, and the body has a tendency to move along the tangent AT with the linear velocity v. If an external force, that is centripetal force Fc, is acted radially inwards along this direction, That means Fc is acted on the body. If the centripetal force Fc is acted on the body along AO, radially inwards, in that case the body will be moving along the curved path AB. That means resultant motion of the body will be along the curved path AB, and the body will rotate in anti-clockwise direction in this circular orbit. R is the radius of the circular orbit. Centripetal force Fc acts radially inwards along AO, and its linear motion will be converted into circular motion along the curved path AB in this horizontal circular path or circular orbit. So circular motion occurs along AB under the action of centripetal force Fc, which acts radially inwards. So the body has a tendency to move along this tangent AT with tangential velocity v, and this linear motion will be converted into circular motion under the action of centripetal force Fc, which acts radially inwards. Number 2 formula, centripetal acceleration. Centripetal acceleration. We can draw the diagram, that is circular orbit, horizontal circular orbit. R is the radius of the circular orbit, and a body, this is a body which is placed at the point A. Body has mass m, which is placed at the point A. The body has tangential velocity. The body has tangential velocity v, or linear velocity v, along the tangent AT. M is the mass of the body, and the body will be moving along the curved path AB in anti-clockwise direction if a centripetal force Fc is acted along AO. Acted on the body along AO, centripetal acceleration AC acts radially inwards. And centripetal acceleration AC has the expression Fc by m, means centripetal force divided by mass is the centripetal acceleration. So we can prove that AC equal v square by r, which is the main expression of centripetal acceleration. AC equal v square by r, square of linear velocity divided by radius of the circular orbit, which is centripetal acceleration, which acts radially inwards. AC equal v square by r, which is the centripetal acceleration of a body of mass m moving in a circular orbit of radius r, AC equal v square by r. So along the tangent AT, the body has the linear velocity v. V is the linear velocity or tangential velocity. But the body will be moving along the curved path AB under the action of centripetal force Fc, and if we divide centripetal force Fc by mass, then we get centripetal acceleration AC. Therefore AC equal omega square dot r. Centripetal acceleration has the third expression, which is AC equal omega square dot r, square of angular velocity and into radius of the circular orbit. AC equal omega square dot r, where omega is the angular velocity of revolution of the body. Omega is the angular velocity of revolution of the body. In the diagram, if the body moves anti-clockwise in horizontal circular orbit, angular velocity omega will be acting vertically upwards, acting in vertically upward direction. AC has another expression v into omega, v dot omega. So centripetal acceleration is the product of tangential velocity v and angular velocity omega. Number 3 topic is centrifugal force. Centrifugal force. Number 3 topic is centrifugal force. In the diagram, we should consider a circular orbit. Here centripetal force is Fc prime, which is which has the same magnitude as that of centripetal force. Mod vector Fc prime is equal to mod vector Fc. Fc prime is the centrifugal force and Fc is the centripetal force. This is a horizontal circular orbit. R is the radius and a body of mass m. Body of mass m is placed at the point A. The body has a linear velocity v along the tangent AT. The body has a tendency to move along the tangent AT with linear velocity v, and the body will be moving along the curved path AB. The body will be moving along the curved path AB, provided a centripetal force Fc, an external force, that is centripetal force Fc, acts radially inwards on the body. This is radially outward direction. Ax is the radially outward direction. Centrifugal force Fc prime. Fc prime acts radially outwards means centrifugal force Fc prime acts along Ax. Therefore, Fc prime has the expression Fc prime equal mv square by r. Therefore, Fc prime equal m omega square r. Fc prime equal mv square by r and Fc prime equal m omega square r. Fc prime equal mv square by r, which is centripetal force, centrifugal force, which has same magnitude as that of the centripetal force. Centrifugal force which acts radially outwards. But centripetal force acts radially inwards. If centripetal force Fc is removed, that is, if the centripetal force Fc is removed, then the body moving in a circular orbit, moving in a circular path, will regain its linear motion, along, number one case is what, along the tangent AT, along the tangent AT, with respect to the static frame of reference. Static frame of reference means a frame of reference which is at rest with respect to static frame of reference P. So this is the circular frame of reference which is not the static frame of reference. And if we consider a straight line, or so this is circular frame of reference which is also revolving in anti-clockwise direction in horizontal plane. Q is the circular frame of reference. Circular frame of reference. And if we consider another frame of reference which is at rest, that is called static frame of reference. In this case, P is the static frame of a reference, and the body will regain its linear motion along the tangent AT with respect to an observer standing in static frame of reference P, and the body will regain its linear motion along Ax, means it will regain its linear motion radially outwards with respect to an observer standing in circular frame of reference, or same type of frame of reference, same type of frame of reference as that of the body which is moving in a circular orbit, same type of frame of reference, revolving or rotating in the same direction with the same angular velocity as that of the body, in the same direction with the same angular velocity. In this case, it is written as in the direction, but it should be in the same direction with the same angular velocity as that of the body. Due to, and the body will regain its linear motion along the tangent or along the radially outward direction under the action of centrifugal force. Under the action of centrifugal force. So this is the horizontal circular orbit. M is the mass of the body. The body has a linear velocity v along the tangent at, and the body will be moving along the curved path AB if an external force Fc, which is centripetal force, is acted radially inwards on the body. R is the radius of the circular orbit. And this radius R is measured from O to A, radially outwards. Along AX, centrifugal force Fc prime acts. If Fc, centripetal force, is removed, that means Fc is made to 0. Along AT, the body has a tendency to move along the tangent AT, and it will be converted in the linear motion is converted along the curved path AB. That means the linear motion will be converted into circular motion under the action of centripetal force Fc, which acts radially inwards. If centripetal force Fc is removed, that means Fc is reduced to 0. That means centripetal force is removed. In that case, the body will regain its linear motion along the tangent AT under the action of centrifugal force Fc prime with respect to an observer in static frame of reference. With respect to an observer in static frame of reference P. The observer in static frame of reference P will observe that the body will be moving along the tangent AT, or that the body will regain its linear motion along the tangent AT if centripetal force is removed. And Q is the circular frame of reference which is revolving in the same direction, and this frame of reference, or that means the frame of reference Q, is same type of frame of reference as that of the body moving in a circular orbit. Same type of frame of reference, rotating with the same angular velocity in the same direction as that of the body. If centripetal force Fc is removed, in that case the observer standing in the frame of reference Q, if Fc is removed means Fc is reduced to 0, the body will regain its linear motion along AX, means radially outwards, under the action of centrifugal force Fc prime. Number 4 topic is maximum speed. Number 4 topic is maximum speed for taking a turn by a car or vehicle around a rough carved road. Maximum speed for taking a turn by a car around a rough carved road. So we should consider a circular orbit or circular path or curved path which is rough, and it will offer frictional force against the motion of the car. So R is the radius of the curved path, O is the center, and this is a car. Two wheels. The car will be moving along this imaginary circular orbit. The car has tangential velocity. Along this V is the tangential velocity with which the body will be revolving in this curved path. Centripetal force Fc acts radially inwards, and due to the centripetal force Fc, the car will be revolving in this curved path. The car has a tendency to move radially outwards, and kinetic friction acting on the wheel, acting between the wheels of the car and the road, is Fk, which acts radially inwards. This is the kinetic friction. Fk is the kinetic friction which acts radially inwards. This kinetic friction Fk provides the necessary centripetal force Fc, and the expression of maximum speed for taking a turn is Vmax equal root over mu rg. Vmax equal root over mu rg, which is the maximum speed for taking a turn, by a car, round a rough carved path, round a rough carved road. This is a rough carved road where mu is the coefficient of friction or coefficient of kinetic friction between the wheels of the car and the road. Mu is the coefficient of friction of the road, and r is the radius of curvature of the rough carved path. R is the radius of the carved path or carved road. Vmax equal root over mu rg. Additional information. In this case, kinetic friction Fk in the diagram, which is acting radially inwards, supplies necessary centripetal force Fc for revolution of the car in this rough carved road. Kinetic friction Fk supplies necessary centripetal force Fc and in this case Fc is equal Fk, kinetic friction Fk equal mu mg, and Fc equal mv max square by r. Here it should be mv max square, here it is written as mv square. It should be mv max square because the car has to turn with maximum speed. That's why it should be v max square. This is the car, weight of the car, that is mg, acts vertically downwards. R is the normal reaction on the car applied by the rough road. R is the normal reaction, capital R is normal reaction. Kinetic friction Fk acts radially inwards or towards left. R is the normal reaction. In this case, R equal mg. Number 5 topic. Maximum speed. Number 5 topic is maximum speed for taking a turn by a car, maximum speed for taking a turn by a car around a rough incline, round a smooth inclined plane, not an, it should be a smooth inclined path or road, a smooth inclined carved road. Maximum speed for taking a turn by a car around a smooth inclined carved road or carved path. This is the smooth inclined carved road. R is the radius of this carved road. R is the radius of this carved road. O is the center. And this is a diagram of vehicle which is revolving along this inclined carved path. Weight of the car, that is mg, acts, weight of the car, that is mg, acts vertically downwards, and this weight mg is resolved into two rectangular components. This angle theta is the angle of inclination, and we can prove that AB is the inclined plane, and we can prove that this angle will be again theta, and mg cos theta is the rectangular component of the weight mg, and mg cos theta acts perpendicular to the inclined plane AB, and we can denote the normal reaction acting on the vehicle or car. R is the normal reaction. R in upper case, capital R is the normal reaction which acts upwards and perpendicular to the inclined plane AB. This normal reaction R can be resolved into two rectangular components. This angle will be theta, vertically opposite angle, and this component is R cos theta, which acts vertically upwards, and this component of R is R sin theta. The component R sin theta is acting parallel to the horizontal plane AC. Centripetal force Fc acts radially inwards along the radius, and in this case this is the smooth inclined carved path or carved road, and the car on this inclined road will be moving with a tangential velocity v along the tangent AT. The car will have the tangential velocity v. At equilibrium, R sin theta equal Fc, that means the rectangular component of normal reaction R, that is R sin theta, supplies necessary centripetal force Fc. R sin theta supplies Fc in radially inward direction. R cos theta balances the weight of the car, that means R sin theta balances mg. And we can prove that Vmax equal root over tan theta Rg. Vmax equal root over tan theta dot Rg. Vmax equal root over tan theta Rg, which is the maximum speed, and here theta is the angle of banking. Maximum speed for taking a turn by a car round a smooth inclined road. Vmax equal root over tan theta Rg, where Fc equal m Vmax square by R. Additional information: the rectangular component R sin theta of the normal reaction R acting on the car by the inclined road, normal reaction R on the car, provides the necessary centripetal force Fc. Provides the necessary centripetal force Fc equal m Vmax square by R, because it will be maximum centripetal force. Number 6 topic is maximum speed. Maximum speed for taking a turn by a car. Maximum speed for taking a turn by a car in a rough inclined carved road. It is rough and inclined carved road. We can draw the diagram. This is the rough inclined carved road. AB is the inclined plane. R is the radius of the carved road. Theta is the angle of banking or angle of inclination, and this is a car which is revolving in this carved road. Weight of the car, that is mg, acts vertically downwards as shown in the figure, and this weight mg is resolved into a rectangular component mg cos theta. This angle is theta, we can prove this, and mg cos theta is the rectangular component of the weight mg, and mg cos theta acts perpendicular to the inclined plane AB. We can denote normal reaction R and rectangular component of normal reaction. R is the normal reaction which acts in the opposite direction of mg cos theta, and R cos theta is the rectangular component of normal reaction R, and this is another rectangular component of R, that is R sin theta, which acts towards left parallel to the horizontal direction. Now we can denote the kinetic friction acting between the wheel and the inclined curved rod. This is what the kinetic friction Fk. Kinetic friction acts down the inclined plane AB. Fk is the kinetic friction which acts down the inclined plane, and this kinetic friction Fk is resolved into two rectangular components. This angle will be theta, and this component which acts vertically downwards is Fk sin theta, and the component which acts parallel to the horizontal is Fk cos theta. This component is Fk cos theta, and the vertical component of Fk is Fk sin theta. The rectangular component of kinetic friction Fk, which is acting vertically downwards, is Fk sin theta. And centripetal force Fc acts radially inwards along AO. In this case, R sin theta plus Fk cos theta is equal Fc, and R cos theta minus Fk sin theta is equal mg. And we can prove that the maximum speed for taking a turn is Vmax equal root over tan theta plus mu divided by 1 minus mu tan theta, bracket closed, Rg. Vmax equal root over tan theta plus mu divided by 1 minus mu tan theta into Rg. That is the maximum speed. For taking a turn in a rough inclined curved road. Vmax equal root over tan theta plus mu divided by 1 minus mu tan theta into Rg. Additional information: in this case, R is the normal reaction acting on the car applied by the rough inclined curved road, and Fk, kinetic friction Fk, is mu into R, where R is mg cos theta. Fk equal mu dot R, which is the kinetic friction acting between the wheels of the car and the inclined road. In the diagram, R sin theta plus Fk cos theta supplies necessary centripetal force Fc, which acts radially inwards. R cos theta minus Fk sin theta balances the weight mg. So finally we get Vmax equal root over tan theta plus mu divided by 1 minus mu tan theta into R.